AP Chemisters, this is Mrs. Vanderlei bringing you another edition of Chapter 10, Blank Wall. This is 10.3. My notes had the 10.3 at the bottom, but this is really section 10.3. And Oops. What this does in section 10.3 is it addresses what we haven't talked about yet. Notice everything we did in section 10.2, your 5 basic shapes. That was your linear, your trigonoplanar, your tetrahedral, your trigonal bipyramidal, and then your octahedral. What did we not take into account in any of those were the lone pairs. So you do need those 5 basic shapes come into memory, and then watch what happens when we introduce the idea of lone pairs. Things are going to change. So it says, when considering the lone pairs and discussing molecular geometry, only consider the lone pairs around the what? The central atom. Don't worry about any of the lone pairs that are on the other atoms, just the central atom. So at this point, if you do not have a pencil with an eraser, get it now. We're going to be using that eraser. Okay, so let's first talk about the most common shape, which would be your 4 electron groups. That's your tetrahedral. So there's a couple things that are going to happen with the 4 electron groups with lone pair. So let's look at ammonia, NH3. So let's draw it first. So here's nitrogen. We know there's a lone pair. And remember how we knew that this is like a kind of a bent downwards in 3 dimensions. And the electron geometry with 4 electron groups is your tetrahedral. Okay, so I have 4 electron groups, right? 1, 2, 3, 4. But those lone pair, there's no atom here. It's just 2 little itty bitty electrons. So what am I really seeing is this. All right, and this is what our molecular geometry is, and this will be our trigonal pyramidal. Remember how I made a mistake in the notes and it said trigonal pyramidal for 5 electron groups? I go, oh no, we can't have that. It needs to be trigonal bipyramidal. This is why, because if you have 1 lone pair and 3 bonds, that's what you get. So watch what I'm going to do here. I'm going to start off, this is why you need a pencil with an eraser. So draw your trigonal, or excuse me, draw your tetrahedral real quick. And then with your eraser, erase one of these. I'm going to erase the top one. And this is what you have left. And I don't know if you can see this shape. Look, isn't this a triangle at the bottom? It's a triangle at the bottom coming to a top, and that's your pyramid. So it's trigonal pyramidal. Now what happens to the bond angles? Your tetrahedral right here is 109 if you have 0 lone pairs. But do you see what happens when you have 1 lone pair? Do you actually have 109? No. In a sense, this lone pair has those 2 electrons, and they're repelling to those other, bonds, and they're kind of mushing them a little bit closer together. So your bond angles when you have lone pairs are actually less than 109.5. Okay, so what happens with probably the most common substance on Earth? That's going to be your water. Look how I draw that. Okay, here we have 4 electron groups. 1, 2, 3, 4. So my electron geometry is 4 electron groups, which is tetrahedral. Okay, I'll abbreviate like that. But watch what happens. So here's my tetrahedral for water, and this is where you need to use your eraser again. I have how many lone pairs? I have 2 lone pairs, so I'm going to erase 2 of those, and now what's left? Well, I don't know about you, but it looks pretty bent to me. Okay, it's also called angular, but I think bent is actually more common. So the shape of water is bent, and that's huge when you want to talk about its structure and its function. Okay, so once again, here is my tetrahedral geometry with 109, but now what? We have 2 lone pairs. So what are those 2 lone pairs doing? Repelling even more, squishing those bonds together, and so the actual bond of the hydrogens and oxygen together is 104.5. So those 2 lone pairs are squishing them even closer. Let's go on. So what about three, should be lone pairs, should be lone pairs, and one bond, so HF. Okay, so I have how many electron groups? 1, 2, 3, 4. We know that 4 electron groups is, again, tetrahedral, right? But watch what happens. Use your pencil with an eraser. How many lone pairs, not one pairs, lone pairs do we have? Well, we have 3. I'm going to erase 3 of those. And what does that look like to you? Do you remember what we said earlier? 2 points determine a line. This, again, is linear. And what is the angle of any linear? It's 180 degrees. Okay, so the effect of lone pairs on molecular geometry, if you have a bonding pair, so like the OH of one hydrogen and OH of the other one, you have the least repulsion. But if you have lone pairs, I'm sorry, let me go back. So if you have, let's say, no lone pairs, you're going to have the least repulsion. If you have some lone pairs, you have medium repulsion. And if you have lots and lots of lone pairs, you're going to have the most repulsion. All right, the least bond angle until you get to linear. This is an N. And then with linear, of course, it's going to be 180 degrees. Okay, what about here? Oh, this is our description here. So I have no lone pairs, 1 lone pair, 2 lone pairs. Good. So let's talk about the 5 electron groups with lone pairs. This is the fun stuff. I don't know about you, but I thought this was kind of fun. So it says draw 1 lone pair and 4 bonds. Now, do you remember when I drew the sulfur before? Here's my S, my P. How many, I'm sorry, here we go. How many open spots do I have? I only have 2. So remember, we have the 3D orbital empty but available. So what would happen if I were to take that down arrow and promote it here? How many open spots do I have? I have 4 open spots. So I have 1 lone pair and 4 bonding angles. So I have 1 lone pair and 4 bonding angles. Remember, these lone pairs around the fluorine do not count towards anything. So I have 1, 2, 3, 4, 5. So my electron geometry is 5 electron groups, which is trigonal bipyramidal. I'm going to abbreviate it because I'm running out oops, there we go, because I'm running out of room there. And so, but then what? Let me show you something. I'm going to erase this because I need the room. Take your pencil, and remember how I showed you in 10.2 how to draw this. I'm going to take it straight up and down and then do it like this. Remember that? So where do I erase? I would erase this one right here. Okay, and if you look at it sideways, if I could tilt this around, and does it kind of look like this? I moved it like 90 degrees. What kind of a childhood playground apparatus does that look like? It's a seesaw, and that's the actual name of it. It's called seesaw. And what are your bond angles? Well, you have 90 degrees and 120 degrees. But wait a minute, what happens to that number? All right, unfortunately, it's going to get mushed maybe a little bit right here. So your bond angle is going to just be probably a little bit under 120. I don't think they really make a big deal about that one though. So it's called seesaw. Let's look at the next one. Draw 2 lone pairs and should be in 3 bonds. There's another typo. Man, wonder what happened when I made these notes up. So let's do this. Hey, look at bromine. Isn't it kind of weird? Here's my S. Oops, silly me. Try this again. All right, there's my 7 valence electrons. How many bonding electrons do I have? I've only 1. How many do I need now? I need 3. Hey, do you remember what's available? The 3, or actually it's a 40, isn't it, is available. So what can I do? I can take this down arrow, just the down one, and I'm going to promote it. How many open spots do I now have? Looks like I have 3 open spots, which is exactly what I need for BRF3, bromine trifluoride. So let me draw this. I have bromine with 2 lone pairs. All right, I'll go like this. Here's my fluorine, here's my fluorine, here's my fluorine. Remember, you want optimal distance away. Okay, so now what? The electron geometry, I have 5 electron groups as I had before. So it's trigonal bipyramidal. Okay, my molecular geometry, however, is going to be this. Now watch, here is my, oopsies, here is my general shape. Oh, heavens forbid. Let's try this again. There we go. And now how many am I going to erase? Well, I have 2 lone pairs, don't I? 1 lone pair, 2 lone pairs. Oh, 1 lone pair, 2 lone pairs. It's consistent. So I'm going to take away these. Okay. And that's going to be my general shape. Now again, if I turn it sideways, what letter does that look like? Yep, it's called T-shape. Okay, so notice when you're working with the 5 electron groups, you only take away from the middle. Do not take away the top and bottom. You want those, these folks to be as far away as they can from each other. So they're going to remain 180 degrees away from each other. Okay, what are your bond angles? You have all 90 degrees. Okay. Okay. Let's try the next one. What if I have 3 lone pairs and 2 bonds? Well, holy cow, look at this next one. Xenon. That's a noble gas. There's no empty, or single electrons to bond with. Well, do you remember what we can do? There is an empty d orbital, so if I take this one here, I can promote it into the d level, and what have I created? I now have 1, 2, 3 lone pairs and 2 bonds. So here's my xenon. I have 3. Yep, they're going to go in the middle, and I guess those are fluorines, aren't they? And they probably look like this. So if you start with that base shape, I'll help you do this again. 5 electron groups is trigonal bipyramidal, right? And my molecular geometry, watch. So here is my basic shape. How many am I going to take away? How many lone pairs do I have? I have 1, 2, 3 lone pairs. What does it look like? It looks linear to me. And what's the bond angle of linear? As always. Okay, so that would be your 5 electron groups. You only have 3 basic shapes for 6 electron groups, the first one being octahedral. You're only going to have 1 lone pair or 2 lone pairs. So let's try these. Well, let's do boron again. Here's S, here's P. Oh no, I only have 1 single electron to work with, so I'm going to promote this one. And I'm going to move it up. Well, now I have 3 open spots, so I need to promote 1 more. And now I have 5 empty spots. So that works. So look, I have 1 lone pair. So bromine, I have 1 lone pair. And then I have 4 bonds. 1, 2, 3, 4. Oops, I'm sorry, 5 bonds. What did I say? 4. So here's fluorine, 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 fluorine. And put your dots around it. So here I have my octahedral. And it said to erase the bottom one. So I started off with 6 electron groups, which is octahedral. My molecular geometry here, well look, I have a square at the bottom and it points up. This is a square pyramidal. Okay, and the bond angles are all going to be 90 degrees, all of them. Okay, and last but not least is this one. So here's xenon. You just trust me here. I had to promote 2, so I have 2 lone pairs and then 4. So if I were to do this, here is my octahedral, and erase with your eraser. So I start off with 6 electron groups, which is octahedral. But now what? I just have a plain old square. It doesn't come up to the point, so it's square planar. And again, it's 90 degrees. All right, stay tuned. We have a little bit more to go.